Hello, I'm Taylor. I'm a math teacher from Oregon. Today we're going to talk about the chord of a circle and the theorems that go with that. GXWeb is going to help us visualize this. Let's draw a circle first, and I want to remind you that a chord is a line segment that joins any 2 points on the circumference of a circle. We're just going to draw 2 random chords here. We have chord B, C, and chord D, E. And we're going to set those chords equal to each other for the sake of discovering this theorem. If we have 2 chords that are equal in length, let's see what the central angles are. So angle BAC is 93.032, and then the other angle DAE, is 93.032, the same thing. Our first theorem is that chords which are equal in length subtend equal angles at the center of the circle. And let's see another example of that. 2 random chords, set them equal to each other, and these central angles that they create should be the same. Angle CAB is 49.014. Angle DAE is 49.014. Let's take a deeper look into why this is the case. Any straight line from the center to the circumference of the circle is going to be the radius. That radius is the same length anywhere around the circle. So with blue, I'm just going to mark that's a radius, that's a radius, that's a radius. All of these lines are going to be the same length. And if we take these triangles that we've created on this circle and we draw them out right here, we can use the SSS, or the side-side-side congruence, which states that if all 3 sides of one triangle are congruent to the 3 corresponding sides of another triangle, then the 2 triangles are congruent, which means the angle at the center will be congruent. So we've gone into the proof a little bit. Let's go back to the theorem in general. Now let's draw another 2 random chords and see if the reverse applies. So now I'm going to set these central angles equal to each other. Let's call them x. And let's use GXWeb to calculate the distance between these 2 points. So the length of that chord is 4.65. And then the length of this chord, distance ED, is 4.65. So this theorem works in reverse. If we have 2 chords and they create central angles that are the same, then the length of the chords will be the same too. Equal angles, equal chords. Let's see another example of this. Say we have 2 chords, and when they create angles at the center, they're both 35 degrees. Chord DE is 1.7, and the other chord is 1.7 as well. That was fast. Okay, I'm going to show you the last kind of theorem that goes with the chords in a circle. So the statement is the equal chords of a circle are equidistant from the center of the circle. So if we draw a line through the center point of each chord, and then we calculate the distance between that chord and the center of the circle, both of the chords are going to be equidistant from the center. First chord is 2.697 away from the center of the circle, and the second chord is the same distance away. Even as we change the length of these chords, you can see in the animation here, these chords remain equidistant from the center of the circle. Let's do that one more time for good measure. Haha, measure, get it? Because we're working with angles. Okay, let's set the chords equal to each other, and then mark the center point so we can calculate how far the chords are from the center of the circle. So the first chord we drew is going to be 1.272 away from the center of the circle. Second chord we drew Equidistant. That is all. Thank you for watching. Remember to like and subscribe. I put the GX link below. All right, see you later.